Are you tired of feeling vulnerable online, spied upon, censored? Protect your digital life with NordVPN, the cybersecurity solution that keeps you safe in your own online bubble. With NordVPN, you can browse, stream, and work worry-free, knowing your data is secure from prying eyes. Imagine having access to over 6,400 ultra-fast servers in 111 countries, ensuring a stable connection wherever you go. NordVPN offers uninterrupted streaming, easy setup, and cutting-edge encryption. But that's not all. NordVPN goes beyond basic protection with features like malware scanning, ad blocking, and a strict no-log policy. Plus, you can secure up to 10 devices with just one account. Don't compromise on your online security. Visit bytes.com/NordVPN now to grab our special deal and enjoy up to 74% off plus 3 extra months. Plus, there's a money-back guarantee. Link is in the show notes and on our website. Take control of your digital life today with NordVPN. The link again, bytes.com/NordVPN.
Welcome to Astronomy Daily. I'm Anna, bringing you the latest fascinating developments in space and astronomy. Today, we have an exciting lineup of stories that take us from groundbreaking technological advances right here on Earth to ancient mysteries of our cosmic neighborhood. We'll explore how New Zealand is making history with Starlink's direct-to-smartphone service, dive into the complex legal framework emerging around space mining, and get the latest updates on SpaceX's Starship program. Then we'll venture into the early universe to examine a mysterious dormant black hole that's challenging our understanding of cosmic evolution, and wrap up with new discoveries about our moon's age that might require us to rewrite some history books. So strap in for another journey through the cosmos as we explore these remarkable stories that continue to expand our understanding of space. In a groundbreaking development, New Zealand has become the first country in the world to offer nationwide direct-to-smartphone messaging through SpaceX's Starlink satellite network. Telecommunications provider 1NZ has launched this revolutionary service, bringing connectivity to the 40% of New Zealand's landmass that previously had no cell coverage. This isn't just about connecting remote terrestrial areas. The service extends approximately 20 kilometers out to sea, covering New Zealand's territorial waters. While currently limited to text messaging, this represents a significant first step in bringing satellite-based communication to standard smartphones. Currently, messages can take up to 10 minutes to deliver as SpaceX continues to expand its constellation, though this is expected to improve to just 1 minute once more satellites are deployed. The service is being offered free of charge to 1NZ's monthly subscribers. Though there's a catch. Only 4 smartphone models are currently compatible with the technology. SpaceX isn't stopping here. They've already launched over 300 satellites equipped with direct-to-phone capabilities, and they have permission to deploy up to 7,500 more. They're also seeking approval to increase signal strength to enable voice and data services in the future. This development in New Zealand is just the beginning. SpaceX has similar agreements with telecommunications companies across the globe, including T-Mobile in the United States, KDDI in Japan, and Rogers in Canada. As the technology continues to evolve and more satellites are deployed, we could be witnessing the early stages of truly universal mobile connectivity, where traditional cell towers become optional rather than essential infrastructure. For SpaceX, this represents another revenue stream beyond their traditional satellite internet service, putting them on track to reach nearly $12 billion in revenue next year. With over 6,800 satellites now in orbit, Starlink has established itself as the world's largest satellite constellation, and it's clear they're just getting started. Next up, as we look to the stars for resources, the legal framework governing space mining is becoming increasingly important. Right now, NASA's Psyche spacecraft is en route to an asteroid that could theoretically contain minerals worth an astronomical $100 quintillion. While that number is more theoretical than practical, it highlights the incredible potential of space resources. The foundation of space law remains the Outer Space Treaty from 1967, which explicitly states that outer space and celestial bodies cannot be subject to national appropriation. However, this doesn't necessarily mean mining is prohibited. Think of it like fishing in international waters. While no nation can claim ownership of the ocean, you can still catch and own the fish. The Artemis Accords, established in 2020, have provided some clarity by explicitly stating that space resource extraction doesn't constitute national appropriation. With 48 nations now signed on, there's growing international consensus about the legitimacy of space mining activities. Several countries, including the United States, Japan, Luxembourg, and the United Arab Emirates, have already enacted national laws permitting ownership of extracted space resources. This is creating a foundation for commercial space mining operations, though significant legal questions remain. One interesting development is the concept of safety zones around mining sites. While space may seem infinite, competition for valuable resources like water and helium-3 on the moon could lead to conflicts. The Artemis Accords attempt to address this by establishing guidelines for these zones, though their exact scope and implementation remain to be determined. As we move closer to actual space mining operations, the distinction between resource extraction and territorial appropriation will become crucial. Companies investing in space mining technology will need assurance that their operations are legally protected and that they'll have rights to the resources they extract. This balance between encouraging commercial space development while preventing territorial claims will be key to the future of space mining. The legal framework continues to evolve as we prepare for this new era of space resource utilization. While the fundamental principle remains that no nation can claim sovereignty over celestial bodies, there's growing acceptance that sustainable resource extraction can be conducted within international law. Next, a SpaceX update. The Federal Aviation Administration has just cleared another major milestone in space exploration by approving SpaceX's 7th flight of their massive Starship vehicle. This approval came earlier than expected and includes some interesting modifications to the launch license. While the flight will follow a similar trajectory to previous launches, this time SpaceX will be using their upgraded Block 2 ship, paired with a Block 1 booster. What's particularly noteworthy is that the FAA has allowed this mission profile to be used multiple times, giving SpaceX more flexibility for future suborbital flights. The company has been busy preparing Ship 33, their first Block 2 vessel, which recently completed crucial engine testing at their facility. The tests included a full 6-engine static fire and a single-engine test simulating an in-space burn, a critical maneuver for future orbital missions. Meanwhile, Booster 14 is nearly ready for flight, requiring only its hot stage ring installation before stacking. SpaceX teams are putting the final touches on both vehicles while continuing pad refurbishment work at their launch site. Looking at the timeline, all signs point to a potential launch around January 11th. NASA has already positioned observation aircraft in Perth, Australia for that date, suggesting we might see another late-day launch to capture stunning images of the vehicle during its flight. One interesting detail in the FAA's approval is the addition of the new failure mode exceptions. These allow SpaceX to test different approaches to in-space burns and post-booster catch procedures without triggering automatic investigations if something goes wrong, as long as there are no safety issues or injuries. Before launch, SpaceX will likely conduct at least one tanking test, if not a full wet dress rehearsal, given this is the first Block 2 ship to connect to their orbital tank farm. These tests will ensure all systems are functioning properly before attempting their most ambitious flight yet. Now, an inevitable black hole update. In a fascinating discovery that's challenging our understanding of the early universe, astronomers using the James Webb Space Telescope have spotted an unusual sleeping giant, a dormant supermassive black hole that existed just 800 million years after the Big Bang. What makes this finding particularly intriguing is both its massive size and its surprisingly quiet nature. This cosmic behemoth weighs in at about 400 million times the mass of our sun, making it the most massive black hole JWST has observed from the early universe. But here's where it gets really interesting. This black hole appears to be taking a nap after what scientists believe was a period of excessive feeding. Unlike most active supermassive black holes that are constantly devouring nearby matter, this one is consuming gas at just 1/100th of its maximum possible rate. It's essentially the cosmic equivalent of passing out on the couch after an enormous feast. What makes this discovery particularly puzzling is that it further complicates an existing mystery in astronomy: How did these supermassive black holes grow so enormous so quickly in the early universe? The traditional understanding suggests it should take over 1 billion years to create a black hole of this size. Yet here we are finding one when the universe was less than 1 billion years old. The research team believes they might have an answer. Their simulations suggest these early black holes may have gone through periods of extreme overfeeding, briefly exceeding what's known as the Eddington limit, the theoretical maximum rate at which a black hole can consume matter. These feeding frenzies would last for 5 to 10 million years, followed by much longer 100 million year napping periods. This sleeping giant might just be the tip of the cosmic iceberg. Scientists suspect the early universe could be full of these dormant monsters, though their quiet nature makes them particularly challenging to spot. It's a breakthrough that's giving us new insights into how the universe's most massive objects formed and evolved in its earliest days. Now, a quick question. How old do you think our moon is? The moon, our constant celestial companion, may be hiding its true age beneath a deceptive volcanic facade. New research suggests our lunar neighbor could be more than 100 million years older than previously estimated, pushing its birth closer to the formation of our solar system. Traditional age estimates based on Apollo mission samples pointed to the moon being around 4.35 billion years old. However, several pieces of evidence have been hinting at an earlier origin. Rare lunar zircon minerals suggest a birth date closer to 4.5 billion years ago, and computer simulations of planetary formation indicate that the kind of massive collision that created the moon was more likely to have occurred during the solar system's tumultuous early days. The key to this age discrepancy might lie in a massive lunar makeover. Scientists now believe the moon experienced a significant remelting event about 4.35 billion years ago, effectively resetting the age recorded in its surface rocks. The culprit? The same force that causes our ocean tides, Earth's gravitational pull. When the moon was young, it orbited much closer to Earth, experiencing far more intense tidal forces than it does today. These forces would have caused widespread upheaval and intense heating across the lunar surface, essentially giving our satellite a complete volcanic facelift. This process could explain why we find fewer early impact basins than expected. They were simply erased by this global remelting event. Computer models now suggest the moon actually formed around 80 million years after the solar system's birth, making it significantly older than previously thought. This new timeline helps reconcile competing theories from different scientific disciplines and provides a more complete picture of our moon's dramatic early history. And that brings us to the end of today's fascinating journey through space. I'm Anna, and I want to thank you for joining me here on Astronomy Daily. If you're hungry for more space news and discoveries, head over to astronomydaily.io, where you can listen to all our episodes, sign up for our free daily newsletter, and stay up to date with our constantly updating newsfeed of the latest developments in space and astronomy. Don't forget to join our growing community on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until next time, keep looking up and stay curious about the cosmos.